Hi, this video is for Monday, March 30th for calculus. So before I can teach you L'Hopital's rule, I first have to teach you or remind you how to find limits analytically by dividing by the highest power of x. But before we get to that, we're going to look at this table. This table is for the function 3x squared over x squared plus 1. So this table shows you how the function behaves as you get closer to negative infinity and positive infinity. So as you can see, as you get closer to negative infinity, we're getting closer and closer to 3. And as you approach positive infinity, we're also getting closer and closer to 3. So these arrows here are showing you what happens with the function as you approach negative infinity. It approaches 3. And as you approach positive infinity, the function is approaching 3. So we can say that the limit of f of x as x approaches negative infinity is 3, and that the limit as x approaches infinity of f of x is 3. Okay, so that's kind of an introduction of what's going to be happening here. So we're going to start with example 1. Okay, now if you remember from last week, we were just plugging in what the limit was approaching, what x was approaching, to find the limit. So we're going to try that on this first problem, and I'm going to show you what happens when you substitute infinity into a function. Okay, so here we go. We're supposed to find the limit as x approaches infinity for 5 minus 2x squared. Okay, so if I'm going to plug in infinity, where x squared is on the bottom of this, we're going to have the following situation. 5 minus 2 over infinity. Now, whenever infinity is on the bottom of a fraction, that portion becomes equal to 0. If infinity is on the top of the fraction, that part equals infinity. So since it's on the bottom here, we're going to have 5 minus 0. And as all of you know, 5 minus 0 is 5. So the limit as x approaches infinity for 5 minus 2 over x squared equals 5. Okay, so that's it. That's the first one. Alright, example 2. We're now going to start dividing by the highest power of x in the fraction. So I'm going to demonstrate that to you. So example 2 says 2x minus 1 over x plus 1. And we're supposed to find the limit as x approaches infinity. So we're looking for the highest power of x in this fraction, and as you can see, the highest power of x is x to the first. So we're going to divide every single term in this fraction by x. So I'm going to demonstrate now. Now once you watch me do this, you might remember doing this in class a while back, where you divide every single term by the highest power of x. Now when you do that, these parts here are going to become 0, because when you plug in your infinity on the bottom of the fraction, those parts become 0. So these parts are going to be 0, this simplifies to 2, and this simplifies to 1. So we're going to be left with 2 over 1, again because these parts become 0, and that means that the final answer is just 2. So the limit as x approaches infinity of this function here is 2. Okay, so hopefully that rings a bell. We did do it a while back. Alright, now on example 3, we're going to have 3 parts to example 3. We're going to find each limit. Okay, so here we go. find the limit as x approaches infinity of 2x plus 5 over 3x squared plus 1. Alright, so what is the highest power of x in that fraction? I think it's x squared. So we're going to divide every term by x squared and see what happens. Okay, so here, since this would just simplify to 2 over x, when we plug in our infinity, this is going to be 0. When we plug in infinity here, this is going to be 0 as well. This simplifies to 3. And this, when we plug in our infinity, is going to be equal to 0. So we have 0 plus 0, and we have 3 plus 0. So 0 over 3 equals 0. So the answer to part A is 0. Okay. Alright, part B, it looks like this. We have limit as x approaches infinity, 2x squared plus 5 over 3x squared plus 1. Alright, so the highest power of x here is x squared. And if you remember from when we did these in class before, once you notice a slight pattern to this, you can do it a lot faster and you don't have to write out every single step. So, for instance, because this says 2x squared here and this says 3x squared there, the limit of this thing is going to be 2/3. But I'm still going to divide by the highest power of x to show you that. Okay, so 2x squared over x squared plus 5 over x squared, 3x squared over x squared plus 1 over x squared. Okay, now this simplifies to 2. This part, when you plug in infinity, is going to become 0. This simplifies to 3. And when you plug in infinity here, this part becomes 0. So we're going to have 2 plus 0, which is 2. And we're going to have 3 plus 0, which is 3. So just like I told you a moment ago, without even doing all this, I knew that the limit was going to be 2/3 because the highest power of x is in both the top and the bottom of this fraction. So 2/3, and our answer was 2/3. Okay. Alright, so we have one last problem. And then you will have a Google form on this stuff. And like always, I'm going to post this video and the notes to Google Classroom. And if you need any help, you can send me a message, an email, and I will get back to you. Okay, so part C looks like this. Find the limit as x approaches infinity of 2x to the third plus 5 over 3x squared plus 1. Okay, so here the highest power of x is x to the third. Okay, so we're going to divide everything by x to the third. Okay. Now, here, my prediction is that we're going to end up having 2 over 0, and that would equal infinity. So we're going to see if that pans out. And I said that because this is the highest power of x. The highest power of x is not in the bottom of this fraction, so that would make the whole bottom part here 0. And this up here, we'd be left with 2. So we're going to divide everything by the highest power of x just to make sure. So this part here is going to become 2. This part here is going to become 0. This part here is going to become 0, and so is that part. So on the bottom here we have 0 plus 0. Because when you plug in infinity for x on both of these, we're going to be left with 0 on the bottom. So 2 over 0, anytime you have 0 on the bottom of the fraction, our brains tell us that's undefined, but when you find limits, that means that it approaches infinity. And if this was negative 2, that would approach negative infinity. Okay, so 2 over 0 means that the limit is infinity. Right? So, I hope that made sense and that you could follow along with how to find limits by dividing by the highest power of x. And if you have any questions, let me know. I miss you lots and I hope to see you soon. Bye.